Do you know how we managed to put so many different functionalities into our mobile phones over the past 20 years? One reason is that we learned to make smaller and smaller electronic components and to use special tools to assemble them together into a tiny but versatile device. However, assembly gets more difficult as we reduce the size of these components. To illustrate the difficulty, I would like you to imagine putting on boxing gloves and then trying to build Legos. Pretty tough, right? Well, just like the example of Legos and boxing gloves, as we try to make ever smaller components as big as only a few atoms, our tools for assembling them together seem more clumsy and inefficient. But there is an alternative way for building things, and that's what my research is about. We may put the idea of having an assembly tool aside and let the building blocks put themselves together, let them self-assemble into the structures we want. Actually, nature has always been building things this way. From gigantic galaxies down to the base protein structures in our bodies, there is no assembling tool putting these building blocks together. Now the question is, can we learn to build things the way nature does? To answer this question, researchers from almost every imaginable field are studying self-assembly. In the case of my project, I study self-assembly as a roboticist. My building blocks are the cubic 3 centimeter size Lily robots, which are specifically designed for this research. Lily robots float in water and are driven around by the flow in the environment. The robots have magnetic connectors, which they also use for communicating to one another. Self-assembly of the Lily robots can be controlled by two means. First, by tuning the flow moving the robots around, and second, by tuning the behaviors of the robots, where each behavior defines how an individual lily makes a decision about joining a growing structure of other lilies. It is through these individual decisions and also numerous interactions that the robots manage to self-assemble. In my experiments, I study the effects of different environmental flows and robot behaviors and try to understand how we can precisely control the self-assembly process in order to build our specific desired structures. So about 3 minutes ago, you probably had never heard about self-assembly. But now you know that it is our ultimate hope for building super small structures, simply by letting things build themselves. Thank you.